performance, and you're going to get a good insight on what we're talking about and how each airplane is different in performance and how they generate power. Just as a reminder, as always, this is considered not to be considered flight instruction. We are starting a discussion, and we want to provide accurate information as well as provide a forum for you to ask any questions you may have and that we can answer. But if you have any more specific, detailed questions, we do encourage you to talk to your CSIP or TCI or flight instructor, and us at Palomar Aviation, always willing to help you guys out. We do Zoom instruction, or we can do on the phone, FaceTime, however you want to do it. We're definitely going to be there for you. But I'm going to go ahead and turn the forum over to Nick for the presentation on the engine and turbo system in the SR series.
Well, hello there, everyone. Good afternoon. Happy Tuesday. Thank you all for joining us again here for another Zoom. Today, I'm going to be talking about the engine and turbo system in the SR series. Our objective today is to understand the operation of the engine on the SR20 and SR22, and we'll also talk about the turbo system on the 22 turbo model as well. We have a few different topics we're going to cover today. We're just going to talk about a general overview of how the system, how the engine works rather. We'll talk about the induction of the engine. We'll talk about turbochargers. We'll talk about ignition, the oil system, indications and limitations, abnormalities, and then we'll talk about the lean of peak versus the rich of peak technique. So between the SR20, 22, and 22T models, each one of these engines are a different model. On the 20 model, we have the IO390 Charlie 3 Bravo 6 model, which is going to be 215 horsepower. On the 22 model, we're going to have the IO550 November model, which is 310 horsepower. And then on our 22 turbo model, we have the TSIO 550 kilo turbocharged model, which produces 315 horsepower. Basically, what the turbocharged version of the engine does is it gives us the same performance at sea level as it does at altitude. An overview of how exactly this engine works: it's a reciprocating engine with pistons connecting to the crankshaft through a connecting rod, which in turn turns the propeller. So it's direct drive. We have an intake valve and an exhaust valve that open and close throughout the combustion process, which connect to the camshaft. It's a 4-stroke cycle engine. Our 4 stages, 4 strokes, are going to be intake, compression, power, and exhaust. Our exhaust system is composed of headers, mufflers, and a heat exchanger, which you can see in the diagram on the side. The induction of our aircraft, the SR2 series, uses a fuel-injected type induction system. So you can see there on our diagram, we have a fuel injector. And basically what this does is it allows us to finely tune the amount of fuel that goes into each cylinder during the combustion process, which allows us to use fuel in the most efficient manner and create the most effective combustion process. The SR20 and 22 are normally aspirated, meaning it takes air in naturally. The air is filtered and the volume of air is controlled by the throttle valve. And as you can imagine, the throttle valve on our aircraft is connected to our throttle handle, which we control inside the cockpit. A manual plunger type alternate air lever is installed on the SR20 and 22 to alter the induction air source, which basically means that to the pilot's right foot on that side, there's a little plunger that you can pull and it'll open the alternate air source. For our ignition system, the magnetos are independent of the electrical system. So if everything failed in regards to the electrical system, the engine still would run. It provides the spark for the engine and also has impulse coupling to improve the efficiency of each stroke. The oil system has a few basic jobs in our engine. It lubricates, it cushions, cleans, cools, and actuates different parts of the engine. It's a wet sump type oil system, which means rather than having a tank of oil on the outside of the engine, we would consider that a dry sump. It has a tank that's located inside the crankcase, which is called what we have a wet sump system. The engine oil is typically kept at right about 180 degrees. For the 22 turbo, We keep about 22 and 22 turbo both. We keep about 6 to 8 quarts of oil. And in our 20, you'll notice our range is a lot lower and it's only 6 to 7 quarts. Cirrus our Cirrus aircraft is equipped with the Garmin engine and airframe unit, which computes all the engine data and relays it to the engine indication system. So we have that page on our MFD that we can pull up to monitor all the different components of our engine. In the normally aspirated SR20 and 22% power is derived from the manifold pressure from the engine, as well as outside air temperature and revolutions per minute. The engine indication system indicates cylinder head temperatures and exhaust gas temperatures through probes on the cylinders and engine manifold. We're also now going to talk about the SR22 turbo model, which does vary slightly in regards to how the engine specifically works. For our induction, we have tuned fuel injectors, again, which vary the amount of fuel that go into the cylinders based on air volume. On the SR22 turbo, our alternate air varies slightly. It automatically deploys if any suction is detected in the induction lines. So you can see on this pipe here that this door has opened because suction was detected. Right here, you're also going to see a blast tube, which blows hot air onto the door to prevent any induction icing on the alternate air source on the turbo model. The SR22 combustion air enters through 2 NACA-type air inlets located on the front of the aircraft. The turbo is force-fed air through the compressor. So you can see we have our compressor down here, which basically takes that air that comes in from the NACA-type air inlets, compresses it, and pushes it through. The compressor spins and pressurizes the air before it is cooled through the intercooler and enters the throttle body, controlling the volume of air. A turbocharger, in essence, just increases the air density before it enters the cylinders. Denser air results in better performance on our aircraft. Exhaust air powers a turbine, which in turn powers a compressor, and the compressor is what increases that air density. A wastegate controls the amount of exhaust air that goes into the turbine. So this wastegate is can be thought of as the brains of this turbo system. From the exhaust manifold, the air moves into a crossover pipe. So rather than having dual wastegates on our newer models, we have a single wastegate in which both exhaust air is directed towards the single wastegate. Before moving on to the wastegate, and then it directs this air to the power turbine. When the wastegate is fully open, it is letting all the air escape. As that wastegate closes, you'll see in the next diagram, it's directing more and more air to the power turbine. The SR22 turbo wastegate is automatically controlled through a sloped controller. So the sloped controller is the brain itself of the wastegate, which basically measures the difference of deck pressure and manifold pressure. Again, like I just said, the difference between manifold pressure and deck pressure. With our sloped controller, we want to keep that pressure differential at about 4 inches of differential. So that is what our system is tuned to do, which is why we want to keep it at about 30.5 inches of manifold pressure during cruise flight. So as you can see, here's the overall look of what happens. So we have air that comes in through the NACA-type air inlets. Air is filtered, it is sent through a compressor. The compressed air goes through the intercooler, and then it goes through the throttle body, goes through its processes of combustion, and then it comes out through this exhaust manifold. And we see we have this wastegate here. This wastegate directs how much air is going into the turbine. So as we can see, this wastegate is closed, so it's going to send all the air through the turbine, and it's going to spin that turbine even faster, which in turn is going to compress more air. A few abnormalities that can occur with this system is an unexplained power loss. It could be a sensor-related issue. It could be a component malfunction. In the SR22 turbo, there's quite a few things that it could be. It could be a leak in the induction system, a leak in the exhaust, a wastegate issue, a turbocharger failure, or even a loss of oil pressure, which in turn would cause you to lose the turbo because the turbo is powered through oil pressure with regards to the wastegate controlling the air. In any case, with any of these kinds of indications, it's hard to diagnose the issue from the cockpit. So the best course of action would be to land as soon as practical, so you can diagnose the issue. It could be, simply a sensor-related issue, or it could be, an exhaust leak or a wastegate issue, in which you can't really diagnose that from the air, and you don't want to find out by other means. For example, the exhaust leak, that's air that's blowing at about 1600 degrees. That air is very flammable because of how hot it is. And when you're mixing it with a bunch of components that have fuel going into them, it's never a good idea to take a risk like that, because it could result in the catastrophic loss of the engine. We'll now talk about the lean of peak versus rich of peak technique. What we're just going to talk about it in simple terms. Our lean of peak technique is best economy, and basically what that does is it uses excess air for cooling, versus our rich of peak technique, which uses best power using excess fuel for cooling. So basically the difference between the two, our lean of peak technique is going to result in a little bit slower cruise air speeds, but it's going to save us a lot more fuel, and it's going to be a lot more efficient, versus our rich of peak technique, which we're using best power and we're using that extra fuel for cooling. It's going to give you a little bit more power, a few more knots true airspeed, but the result is going to be a higher fuel burn throughout cruise flight. Does anyone have any questions on the turbo system or the power plant of the SR20 and 22 turbo series?
So Nick, let's talk about the difference between a normally aspirated airplane and a turbocharged airplane in terms of performance and taking off from, let's say, like a airport like Big Bear, and why having a turbo would be so advantageous for the pilot taking off of a airport that's at a higher altitude.
Right. So our 20 and 22 are normally aspirated, meaning it takes air naturally. And we know that at sea level, air standard pressure is going to be 2.9 or 902. But as we climb up, that air is going to be reduced in density. Therefore, there's less air for the engine to work with. Therefore, it results in a loss of performance. What our turbo system does is it compensates for that loss in air density and compresses that air, which therefore we can get the same performance at sea level as we do at altitude with our turbo.
Right. Yeah. And those are things to take into consideration when you're planning your trips, especially to a place in Southern California like Big Bear, or you're out in Colorado or someplace where there's a lot of mountains that, at a normal altitude, closer to sea level, your SR20 or normally aspirated 22 performs really well. But when you go to an airport that's at a higher altitude, you're not going to get that same performance. So you're going to either have a longer takeoff roll, or you're going to have problems with how much weight you're able to take and stuff like that. And, if you have to clear obstacles at the end of the runway, those are all things that you need to take into consideration. And then, so we've talked about, the difference between the power plants at taking off at altitudes, but how about, when you're in cruise flight, how would you decide, Nick, whether you're in a lean of peak or rich of peak fly your airplane that day? What are some things that you would teach your students to take into consideration?
Yeah, so some considerations may be, are you trying to be as fuel efficient as possible? Are you trying to save a little bit of money on fuel? Well, then yes, you may use the lean of peak, or, it does change the range of how far you can go. So let's say, for example, you could probably get to West Texas from Southern California, and it could be the difference of you making it, halfway through New Mexico on the best power, which is going to give you a few knots of extra airspeed. But best economy, our lean and peak technique, that range is going to be increased quite a bit because you are burning less fuel.
Right. And so I saw Paul put a question in the chat asking if there was tables based off of for speed and horsepower based off of altitude. And per our discussion last week on performance, you could always go into section 5 of the POH and look up and see, based off what the outside air pressure is and density altitude, how your airplane is expected to perform, and especially, take off roll and landing roll and clearing obstacles at the end of the runway. And for all airplanes, any airplane ever, but Cirrus has the my personal opinion, the best performance tables out of any manufacturer out there, because it is very easy to go in and look at the Section 5 and see exactly what your performance data is looking at. And Georgia was asking.
Yeah, I'll answer that question, Georgia. With regards to flying a turbo lean of peak, Cirrus, the manufacturer, actually doesn't give us a rich of peak section in the POH, because the performance that we can get out of the SR22 turbo is so great at altitude that it makes no sense to fly it at rich of peak. So all the performance metrics that the SR22 turbo is based on in the POH, as well as the targets that your aircraft are giving you with regards to leaning, are for lean of peak procedures.
Correct. Yeah, and the newer generation Cirrus that have the leaning, there's a lean assist on the G1000 NXI, but there's also the cyan target that we could hit now as we're leaning, where if you're flying and once you go to cruise power, there's a little target on your fuel flow indicator that will give you the best lean procedure for that airplane. And for the turbo, once you get it about under 30.5 inches of manifold pressure, those targets pop up. But as you fly the different airplanes, the leaning procedures are going to be different, but it all comes out of the POH and what they recommend. And that's why it is very important for you to understand exactly how the airplane flies and getting into that POH, understanding the performance of it. So, you know, for the SR20, when you're flying it, once you get under a certain percent of power, that's when that target comes on. But for the SR22T, it comes on much higher power settings compared to a normally aspirated 20. And that's you'll see all of that in the cruise performance when you're doing your cross-country plane on when you get your true airspeed and your fuel flow. You have to read the conditions that those charts are made under, because if you are under the assumption that you're flying the airplane one way and it's really made to fly the other way, you could either be flying the airplane inefficiently, or you could be actually hurting your airplane if your turbo inlet temperatures are too high. You end up spending more on maintenance on the back end of that. And Nick, can you go back a couple slides to the wastegate diagram? So can you, sorry, never mind. I lost my train of thought on that one. Aiden, do you have anything to add on the normally aspirated airplanes for our 20 for our students at Palomar Aviation on the power plant on that one?
Not a whole lot that I can think of. I think Nick did a pretty good job of summing it all up.
Right. And then, as always, understanding your airplane, even though the SR series is made to fly the same, understanding the different power plants, going from a Generation 5 SR20 to a Generation 6 SR20 is a completely different airplane. You have the Continental engine in one, and then you have the Lycoming engine in another. Those start processes are different. So you really want to make sure that you understand the airplane that you're flying, because from one generation to another, you could have a completely different engine manufacturer. And if you've ever flown a older SR20, that start process is 200% different than the starting process on the newer SR20, which is important. So when you're making that transition, going from a start with mixture full rich to a mixture start on the newer SR20 is it's a learning curve, because you really need to understand what you're doing and understanding how the engines work, and then understanding what happens if you introduce too much fuel into the airplane, and then how to fix that problem without burning out your battery. George, are you talking about why they made it so it's only 2,500 RPM when it's in cruise for the newer airplanes?
Well, in my old Avidyne airplane, you know, you take off, it would be 2,700, and then cruise, you lean it back 25. And this one, it's just always the same, right? And
right.
So why do you think they made that change?
So from what I understand, it was just the performance calculations they made. Having less RPM also reduces the noise, but I honestly don't know the exact reason why they would limit the 2,500 RPM the whole time. But I generally don't question Cirrus on anything they do, because the changes that they do make are always for the better from what I've seen. But if Nick or Aiden had anything to add on that.
I don't.
Yeah, it does affect your, you know, you have to use a little more fuel for that. So I was just curious what their trade-offs were.
I think
yeah, I don't think there's the difference between 200 RPM on, you know, climb out. You do use a little bit extra fuel, but you know, flying the turbo to altitude, you're still getting that really good performance because of how the engine produces the power. So I don't think there's a huge detriment from reducing that 200 RPM on the airplane. I don't know if Nate would know the answer to that or something, but.
Yeah, that predated me as well on that change. We're talking on the turbo, correct?
Right.
The NA still runs 2,700 on takeoff and then reduces to 25 in cruise, but the turbo maintains 25 the whole time.
Right.
Yeah, so that predates me as well. I'm not exactly sure why that change occurred.
Yeah, I like I said, whenever Cirrus makes a change, it's generally for the better. So I haven't questioned them on that. It's something that you need to know about your airplane, but I think that the airplane is so powerful and so efficient already that you might use a little bit more fuel, but then you can also really, you know, lean that airplane out and get it down to a really good fuel flow. And with how quick you get up to altitude, I don't think it's a huge detriment to the performance of the airplane. So does anyone else have any other questions or comments? Cool. Well, I appreciate everyone joining us today for the power plant presentation that Nick gave us. It was incredibly informative, and he did a really good job. And then if you haven't noticed where these diagrams came from, you could always go to the Cirrus Approach portal online and sign up for a transition course. Or if you're an owner, you already have those courses available to you on your portal. And the Cirrus aircraft guys at the factory just came out with some really good videos on the systems, and these systems videos have been incredibly informative, and they also teach us a lot. And it's something that we really appreciate about Cirrus for putting in the effort to make sure that we have all this great information. So I encourage all of you to go online to your Cirrus Approach portal and check out the new systems videos as well as the new CAPS videos. And then, as always, if you have any more questions, contact your local CSIP or TCI at your Cirrus Training Center. Or if you want to talk to us here at Palomar Aviation, you can always go to our website at palomaraviation.com and get in contact with us, and we'll be more than happy to set up any sort of Zoom sessions or FaceTime sessions or phone calls to help you understand these airplanes a little bit better and give you some more quality one-on-one instruction. On Thursday, we're going to be having Aiden give a presentation on weight and balance, and we're going to be doing a lesson on how to do weight and balance by hand, and then also why it's important to do weight and balance before all your flights, even if you're really familiar with the airplane. I just wanted to thank everyone for joining us once again, and I look forward to seeing everyone on Thursday at 2 p.m.
Thank you, guys. Appreciate it.
Thank you all.
Thank you.
Yeah.